In this video, we're going to complete a graphic organizer so that you can have all of your information for rational functions in one place. Reminder that the equation for a rational function is going to be f of x is equal to p of x over q of x, where p and q are also going to be polynomial functions. We're going to take that, we're going to write the function in factored form, and we're going to simplify, then find the x-intercepts. And the way we're going to do that, we're going to do y equals 0, plug in 0, and then that means that in order for again, since it's rational, the only way that that could be true is if the top is equal to 0. So you can actually just do p of x equals 0. To find the y-intercept, we're going to just find f of 0. Next, you can find the vertical asymptotes by setting the bottom equal to 0 anywhere you have discontinuity. However, this is when you have no duplicate factors. And what I mean by duplicate factors is when there's not a factor that's on top and bottom. Now, let's go ahead and write that down. If there's a factor on top and bottom, that's where you have a hole. So I'm going to put that's where you have common factors in p of x and q of x. Now let's scroll back up. Your horizontal asymptotes, if the degree of the top is greater than the degree of the bottom, you will have no horizontal asymptote. However, that's where you need to start looking for a slant asymptote. And I'm going to put slant with a question mark. If the degree of the bottom, or excuse me, if degree of the top is less than the degree of the bottom, then you'll have y equals 0 is going to be your horizontal asymptote. If the degrees are equal, then your horizontal asymptote will be y equals the lead coefficient or leading coefficient of p over the leading coefficient of q. Slant asymptotes are going to be of the form y equals mx plus b. And the way that you're going to find that is by finding the quotient of p of x over q of x. So you're actually going to divide it. And these are improper fractions. If you would like to, you can put it here, improper fractions. You're going to divide the two and ignore the remainder. So now we'll work through some problems just to remind you of these rules. First off, your domain, find all your places where the bottom is going to equal 0. Those will be either, again, vertical asymptotes or they're going to be holes. Since x plus 2 is a factor of the bottom but not also a factor of the top, then it turns it into a vertical asymptote at x equals -2. So therefore, this has no holes. Next up, let's find your either horizontal asymptote or your slant asymptotes. The way you do that is by looking at the degree. The degree of the top and the bottom are the same. So therefore, you're looking for a horizontal asymptote. You take your leading coefficients, which is 3 and 1. So y equals 3 is going to be your horizontal asymptote. Once you find those asymptotes, which we can say now also there's not a slant, once you find your asymptote lines, make sure you graph them. Okay, there's your asymptote lines. Next up, let's find our x and y intercepts. You find your x-intercept by setting the function equal to 0. You'll get -2/3 for your x-intercept, so -2/3 comma 0. To find your y-intercept, plug in 0 for all the x's. So that means that and that goes to 0. Your y-intercept would be 2/2 or 1. Plot those points. From there, you can actually do a table of values along with your asymptotes, and that's going to give you an idea of what your function is going to look like. And I just sketched a general graph there. Your range is going to be all values from -infinity up to, or we can just do it like this. There's only one restricted value in your range. Y does not equal 3 there. Okay, the next one. Same thing, we always factor first, factor the 6 out of the top, and then factor the bottom. Gives you an x minus 3 and an x minus 1. Again, we're going to simplify, and when you simplify, you can go ahead and say, well, since that's simplified, then I have a hole at x equals 3. And my function now looks like this, 6 over x minus 1. Any point of discontinuity that is still there is going to be a vertical asymptote. So there's going to be a vertical asymptote at 1. So my domain restrictions was x cannot be 1 or 3. Next up, you can find your horizontal asymptotes or your slant asymptotes. And the way you do that is by looking at your powers. X to the first on top, x to the second on bottom. Since the bottom is greater, then you have a horizontal asymptote at 0, and you will have no slant asymptote. Let's go ahead and graph those asymptote lines. And also, now that you have this reduced 6 over x minus 1, you can now plug that 3 in to find out where your hole is going to be. Plugging in the 3 for x gives you 6 over 2, which is also 3. So your hole is going to be located at 1, 2, 3, 1, 2, 3, right here. Finding your x-intercepts and your y-intercepts. To find your x-intercept, you set the top of your function equal to 0. There's not going to be an x-intercept. To find a y-intercept, you plug 0 into your function, and you can plug it into your original, and you'll get negative 18 over 3, which is going to be negative 6. So that's going to be 0, comma, negative 6. Let's go ahead and plot that point. Next up, you can either do a t-table, follow your asymptote lines, and that will give you the general shape of your graph. Now for the range, I always like to save the range for last. For the range, you can just put all your excluded values for y. Your y will never be equal to your where your horizontal asymptote is, which is 0, and your y will never be equal to 3, which is where the hole is in the graph. Number 3, you always start out rational functions by factoring, so let's go ahead and factor the top. And in this case, there's nothing that multiplies to give you negative 12 that adds to give you 6, so therefore this is not factorable. So let's check our restrictions, domain restrictions. X cannot equal a negative 4. And since x plus 4, that's not factorable top, then we know that x plus 4 is not a factor of the top. So therefore, that domain restriction will be a vertical asymptote. So we will have no holes in this graph. Since the top function has a degree of 2, the bottom has a degree of 1, there will be no horizontal asymptotes, so we will have a slant asymptote here. The way that you find a slant asymptote is by, again, actually dividing this. So we're going to divide by x plus 4 into 1, 6, negative 12 with synthetic division. Sometimes you might have to use long division. You get this. So therefore, this part is going to be your slant asymptote, which is going to be y equals x plus 2. You don't have to worry about the remainder. So since you have the slant asymptote and the vertical asymptote, let's go ahead and graph those two. Next up, let's find your x-intercepts and y-intercepts. You find your x-intercepts by setting the top of your function equal to 0. Now, since that wasn't factorable, you're going to have to use either a quadratic formula or completing the square to solve this. So there, I went ahead and done that for you. I completed the square, and I found out that my two x-intercepts was going to be located at negative 3 plus and minus the square root of 21, comma 0. And I went ahead and turned those into decimal form so I'd know where to plot those on my graph. So that was located at 1.6, which is somewhere right along in there, and negative 7.6, 1, 2, 3, 4, 5, 6, 7, 8. So somewhere right in there, your x-intercepts. Now to find your y-intercept, we're going to plug in 0 for the x's, which is, again, very easy to just do that. And you get negative 12 over 4. So your y-intercept would be 0, negative 3, which you can plot there as well. Connect your dots by following along your asymptote lines, and that'll give you the general shape of your graph. So there's my graph, and again, you can use a table of values if you would like to actually find exact points on that graph to make it look a little bit better. Your range here would be all real numbers. Okay, number 4. First step is we need to factor our rational function. And here's what I get whenever I do factor it. Notice the bottom, x times x minus 2 times x minus 1 tells me that my domain restrictions, x will not be able to be 0, 1, or 2. Again, anything that cancels out tells me that at that point I will have a hole. So since the x's cancel and the 2's cancel, that means that I will have a hole at x equals 0 and at x equals 2. Now let's find the entire point for those holes. The way that we're going to find those points is by plugging it in the, again, simplified version. So my new simplified version of this function is going to be x minus 6 over x minus 1. When I plug in 0, I get 0 minus 6 over 0 minus 1, which is negative 6 over negative 1, which is positive 6. When I plug in 2 into my function, I have 2 minus 6 is negative 4 over 1, which would give me negative 4. So therefore, I have a hole at 0, 6, and 2, negative 4. The other discontinuity, which was located at x equals 1, then must be a vertical asymptote. We'll then find our horizontal asymptote or our slant asymptote by looking at our powers. We have x to the third over x to the third. You can get it from here, or you can get it from here. Since the powers are the same, then my horizontal asymptote will be the coefficients, which would be y equals 1 over 1. So now we have all the vertical asymptotes, horizontal asymptote. There will be no slant asymptote. And we have the holes, so let's go ahead and graph those. And there you have them. Next up, let's find our x-intercepts and our y-intercepts. Again, we find our x-intercepts by setting our function equal to 0 and making the top of that fraction equal 0. And you're going to get an x-intercept of 6, 0. And you're going to get a y-intercept by plugging in 0 for both of your x's. When you plug in a 0 here and a 0 here, it gives you negative 6 over negative 1, which is a positive 6. So y-intercept of 0, positive 6. I believe that's already on the y-axis. That was actually the hole that was in our graph, so that's an open circle. And then 6, 0 is going to be your x-intercept. 1, 2, start your origin, 1, 2, 3, 4, 5, 6. And that's going to be plenty of information to graph your function. I believe that's everything. So let's connect our dots and look at our function. And it'll look something like that. And again, you can always do a t-table and find some more points to make it look a little bit better. Your points of discontinuity on your range, y will never equal, this is the point, that y value is negative 4. Y will never equal 1 because of your horizontal asymptote, and y will never equal 6. So therefore, down here where I put a y-intercept of 0, 6, since 0, 6 is not a point on your graph, it will not have a y-intercept. Okay, number 5, the first step is we have to factor top. Bottom's already factored. And there's your factored form. Your only discontinuity in your domain, x will not be able to be 1/3 because that would make the bottom of your fraction equal to 0. Since 3x minus 1 is not a factor of a top, that's going to be a vertical asymptote at 1/3, and there will be no holes in your graph. Now let's check for a horizontal or a slanted asymptote here. 3x, let's see, look at the powers of the top and bottom. You have a 2 and a 1, so therefore that's going to be a slant asymptote. You're going to do long division here to figure out what that slant asymptote is. As I divide it, here's what I get. 2x minus 1 minus the remainder. To find your slant asymptote, again, you forget about your remainder. So your slant asymptote will be simply y equals 2x minus 1. Since there's a slant, there will not be a horizontal. Let's go ahead and put our asymptote lines on our graph. And there are our two asymptote lines. Next up, let's find our x and y intercepts. To find your x-intercept, your function has to be 0, so let's set the top of our function equal to 0. And you're going to get a negative 1/2 and a positive 4/3. To get your y-intercept, you can go back to your original since nothing canceled and plug in 0 for all your x's. Those will all cancel and leave you with negative 4 over negative 1, so therefore your y-intercept will be a positive 4. Let's go ahead and put those in our answer blanks and graph them. And there you can see the x-intercepts and the y-intercept graphed, and that should be plenty of information to actually complete our graph. So let's connect our dots and see what it looks like. So there's our graph, and we can now identify the range. It goes down and up in both directions forever. So there is your negative positive infinity range. And the last one. Step number 1, we have to factor both top and bottom. And there is your factored form. And you can actually notice the 4 and negative 2 on top and bottom. You could actually reduce that. It doesn't really matter, to a 2 and a negative 1. Your points of discontinuity would be domain cannot equal negative 2 or positive 2. Notice that you do have the x minus 2 on top and bottom, so that point of discontinuity would be a hole. So you have a hole at x equals 2. So we'll find the actual spot the hole is located in just a second. The other discontinuity, the negative 2, must be a vertical asymptote because it does not cancel. So let's rewrite our function. And to actually find the location of the hole, we now plug in 2. And on top, that'll be 2 times 1, which is 2. On bottom, you have negative 4. So that's going to be 2 comma negative 1/2 when you reduce it. Next up, all horizontal asymptotes are slowed asymptotes. The powers are the same on top and bottom, so we simply look at the values out front, and you can use those values or you can use these. You're going to get the same y equals negative 2 for your horizontal asymptote, so therefore you will not have a slant asymptote. So let's go ahead and put those asymptote lines in the hole on our graph. Okay, next up, let's find our x and y intercepts. And again, to find the x-intercept, you will set the function, or at least the top of it, equal to 0. When you solve that, you'll get that x equals 1. There's your x-intercept, so that would be 1, 0. And your y-intercept you find by putting a 0 in for all the x's, and you can just do that here if you would like. That leaves you with 8 over 8, so you have a y-intercept of positive 1. So that would be at 0, 1. Let's go ahead and plot those 2 points on our graph. And as I do that, I notice I put the hole in the wrong place. That's supposed to be 2 negative 1/2, so that would be right there. That should be enough information to at least finish half my graph. And to get the second half of your graph, the left side to the left of your vertical asymptote, let's plug in maybe negative 3 and negative 4 into a t-table. And when I do, here's the 2 points that I get, and that should be plenty now to finish the rest of our graph. And there is your completed graph, and now we can finish our range restrictions. The only y values not included on your graph is your horizontal asymptote listed at negative 2, and also the hole that was in your graph that had a y value of negative 1/2.